Alright, we want to practice using the chain rule. Now in the notes, we saw this process of taking the derivative of the function in terms of u times the derivative of u, and sometimes that just gets to be a little bit confusing. Alright, and I understand that. So what I want to show you is how I actually think about these problems. What I look for is I look for the inside function. I see that I've got a function inside of something raised to the sixth power. And here's what I do. I blur out the inside in my mind, and then I take the derivative of the outside function. And so f prime of x of the outside is 6 times whatever that blur is, and then subtract 1 from the exponent. And then I go back and I consider the blur. That was 2x plus 5. And then I take the derivative just of what I blurred out. And that's just 2. And then I simplify that to be 12 times 2x plus 5 raised to the fifth. So I start with the outside function, just really ignoring what's on the inside, and then I go back and I look at the inside and I take its derivative and multiply it all together. Let's do another one. Here I want to find y prime, where y equals negative 2 over the fourth root of 6x minus 1. Now before I even worry about the chain rule, I'm going to rewrite that. First thing I'm going to do is I'm going to make that root a fraction, and then I'm going to move the root up to the top, and so that'll be to the negative 1/4. So 1/4 because it was a fourth root, and then negative because I took it from the denominator and moved it up to the numerator. So now what I see is I have this inside function and then my outside function. So ignoring the inside, I'm going to take the derivative of the outside. So y prime is equal to negative 2 and then times 1/4 of whatever that inside was, and then negative 1/4 minus 1 will be negative 5/4. And then I go back and I take the derivative of that inside, which is just 6. So all of this was the derivative of the outside, and then there's the derivative of the inside. And I do this without going through all the charade with the u, right? Let's simplify this. Negative 2 times 6 is 12. Divided by 4 is 3. So I have 3 times 6x minus 1 to the negative 5/4. I don't have to do anything else, but I shouldn't leave negative exponents in my answer, so I'll make this 3 over 6x minus 1 to the 5/4. Let's keep going. Let's keep doing some examples. I'm going to find dy dx, where y equals negative 1 over x squared minus 5x minus 6 squared. First thing I can do, I could do a quotient rule here, but since I don't have a function on top, let's rewrite this as negative x squared minus 5x minus 6 to the negative 2. And here is my inside function. So I'm going to take the derivative of the outside function first. So I have negative 1. So y prime is equal to, got a negative 1 here, times my exponent. And there's my inside. Raised to the negative 2 minus 1 will be negative 3. And then I go back and I take the derivative of the inside of that underlined red part. So the derivative of the inside is 2x minus 5 minus 0. And I'm done with the calculus. Now I'll simplify it, and so I have, let's see, 2 times 2x minus 5. Take my negative exponent and put it in the denominator. X squared minus 5x minus 6 cubed. If the u and the u prime helps you, by all means do it. But I do think you'll have better success, and this is what you'll end up doing anyway once you get used to it. We can use the chain rule in combination with other rules. We can do product rule, we can do quotient rule in addition to the chain rule. So on this one, what I see is I have a first, and I have a second, but my second is going to need a chain rule because I have a function inside a function. 5x to the minus 1 will be my inside, and then my outside is that function raised to the fourth power. And so if I start following my chain rule, f prime of x is equal to the first times the derivative of the second. So to find the derivative of the second, I'm going to do my outside first. So 4 times my blur, and then take the derivative of the inside, which is just 5. Okay, so that was first times the derivative of the second, plus the second times the derivative of the first. And then calculus is done. Now it's just algebra to clean it up. So for that, I'm just going to distribute what I can here. So this will become 20x cubed times 5x minus 1 to the third. So I took 5 times 4 and then times my x cubed. Oh, that should have been cubed there. So there's my 20x cubed times 5x minus 1 cubed. And then for the second term, there's nothing I can really do to clean that up. I'll just write the 3x squared first. So plus 3x squared times 5x minus 1 to the fourth. And that's a good final answer right there. Let's do one more. Let's deal with a trig function. Find f prime of x when f of x is equal to the sine squared of 2x. First thing you should always do when you see sine squared written like this is to rewrite it. That's the same thing as saying the sine of 2x squared. And then here it's easier to see this is my inside function. But what's tricky about this one is you've got a function inside a function inside a function, right? I may have said that one too many times. Anyway, I'm going to have to apply the chain rule twice. So I'm going to start on the outside and work my way in. First, I'm going to deal with this function. So f prime of x is equal to 2 times the sine of 2x. But then I have to take the derivative of that, which is the cosine of 2x. But then I have to take the derivative of that, which is 2. Do you see how I applied the chain rule twice? So I have 2 times 2, which is 4, sine 2x, cosine 2x. And we're done.